Hello viewers. In this session, we will discuss about in situ strength assessment. We require assessment for the particular properties of the concrete mass, and assessment of the properties will be classified in two ways. First one is fresh properties and the second one is hardened properties. If we talk about the hardened properties, so hardened properties has mainly two methods for the assessment, because we have to assure that we are using the concrete mass is capable to give you the hardened property, or you can say the strength of the concrete mass in our existing site. So there are the mainly two methods for the assessment. First one is destructive test and second one is non-destructive test. In destructive test, the concrete is destructed and the damage, and after that we can get the hardened properties of the concrete mass. And in the non-destructive test, we are not destructing or damaging of the concrete mass. So these two methods are applied for the finding the hardened property of the concrete mass. As we have earlier discussion, in the hardened property assessment, we have to analyze the compressive strength, tensile strength, and the bond strength of the concrete mass. And we have already discussed the destructive type test like compression test, tensile strength test, and bond strength test. And in this session, we will discuss about NDT test, non-destructive test, because there are the many methods to assessment of the hardened property of the concrete mass. And if we analyze the test used in the different countries, there is no particular method is acceptable universally. There is uses the many types of the test based on the requirements. Generally, we are using the test based on the destructive test, because this will give you the accurate answer compared to the other methods, because in the destructive test we are preparing the mold for the 7 days and the 28 days, and then we are providing the curing of the concrete mass, and then after the applying the loading, we can get the hardened properties of the concrete for the particular day, like 7 days and the 28 days. This method is used widely in our construction field. But in case of the assessment of the hardened property without damaging or destructing of the concrete, we have to use the non-destructive test, and we can also analyze the time interval strength after the certain periods, and we can analyze the increasing or decreasing the strength graph of the concrete mass. So we will discuss in this session in situ strength assessment with non-destructive test. Let us see the in situ strength assessment, which is classified in two ways for the particular non-destructive test. These are the classified in two methods. First one is non-destructive test and second one is partially destructive test. In the non-destructive test, we are not damaging or destructing the concrete mass and analyzing the hardened properties of the concrete mass. And in the partially destructive test, the sum of the parts will be damaged with this test. And if we talk about the methods, you can see on your screen surface hammer test, rebound hammer test, ultrasonic pulse velocity test, radioactive methods, nuclear methods, magnetic methods, electrical methods. So these methods are classified in non-destructive test. If we talk about the partially destructive test, in this test includes the pull-out test, second one is pull-off test, and third one is penetration resistance test. And pull-out testing machine is classified in two methods. First one is cast-in methods, which is popular as lock method, and the second one is drill hole method, which is popular as capo test, CAPO test. So these tests are classified in partially destructive test. And in this session, we will discuss about the rebound hammer test and ultrasonic pulse velocity in detail. Before the starting this test, we will discuss utility of non-destructive test. First one is to improve the product reliability. Second one is to determine the acceptance to a given requirement. Third one is accident prevention and to reduce cost. Fourth one is to quick information on repair criteria and weld verification in inspection of the raw products, in service damage inspection like cracking, corrosion, erosion and heat damage, etc. So these are the utility of non-destructive test. Now let us discuss about rebound hammer test. Rebound hammer test is one of the most frequently used worldwide for the NDT test, non-destructive testing for the structural concrete elements. And this instrument was developed in 1948. And you can see on your screen this rebound hammer has plunger which is connected with the impact spring, and you can see on your screen other parts of the rebound hammer test. You can see here this is the hammer mass, this is the rider on guide rod and window scale, this is the hammer guide and this is the release cage, and here the compression spring is attached into the rebound hammer, and here the locking button is provided in rebound hammer. And this instrument is work on the principle of rebound of elastic mass of energy, which is dependent on hardness surface of the concrete. And here you can see on your screen this element is firmly pressed on your concrete surface, and the instrument is to be arranged at the 90 degree of the surface of the concrete and then firmly pressed and then release it, and the rebound mass is knotted. Here the plunger with spring is pressed and then release it, then the rebound mass is knotted. Higher the rebound will give you the higher result of the compressive strength of the concrete mass. This instrument is mostly used worldwide for the non-destructive testing of the concrete mass. And with this instrument you can analyze the compressive strength of the increasing with the certain duration, and this hammer is really sensitive, so that if you are measuring the compressive strength of the concrete mass, so this will influence by the different types of the properties of the concrete mass. If you are measuring the concrete mass with having the larger size of the aggregate, so this will give you, and the rebound from the larger aggregate will give you the higher compressive strength of the concrete. And if you are measuring the voids with the larger voids with the concrete mass, so these hollow spaces will give you the lower strength of the concrete mass, so that we have to measure 10 to 12 times with the different area with the different situation, and the average value should be considered for the hardened property of the concrete mass. And here this type of the hammer we can apply with the horizontal surface, with the vertical surface and with the any inclined surface of the concrete mass. And the different angle of the surface, the calibration should be considered for the same. So this is all about the rebound hammer test. Now let us discuss about the result are significantly influenced by the following factors. First one is smoothness of surface. Your concrete surface should be smooth because the smoothness of the surface will greatly affect to the result of the rebound value from the rebound hammer test. Second one is shape, size and rigidity of the specimen. It's really greatly the size and the shape of the element will significantly influence to the result of the rebound value. And next one is the age of the specimen. If you are measuring at the end of the 3 days, this will give you the lower value of the rebound. If you are measuring the compressive strength at the 28 days, this will give you the higher rebound value of the compressive strength for the compressive strength of the concrete. So this will increase the rebound value with increase the age of the concrete mass. Next one is surface and internal moisture condition of concrete, because with the increasing of the moisture content, this will give you the lower compressive strength. So in the concrete mass, the high water content will give you the lower rebound hammer, and with decreasing the water cement ratio, this will give you the higher value of the rebound hammer for the compressive strength of the concrete. And next one is miscellaneous factors like types of aggregate, which type of the concrete you are using in your concrete mass. This will give you the different rebound values in your concrete mass. For example, you are using the harder aggregate, so this will give you the higher value of the rebound of the test. And if you are using the softened aggregate, so this will give you the lower value of the rebound for this test. And next is carbonation of concrete surface. So if the carbonation is occurred in your concrete mass, so this will give you the lower value of the rebound, because this factor is mainly considered for the durability of the concrete mass. Next one is types of cement. Different types of the cement has the different properties, and this will influencing the strength of the concrete mass. If we compare the cement mass of the ordinary Portland cement with the Portland pozzolana cement, the same content, the OPC will give you the higher rebound value compared to the Portland pozzolana cement. Next type is curing of concrete. If we are applying the curing mass of the concrete, so this will increase the hardening of the concrete mass, and with increasing of the curing, this will give you the higher value of the rebound for this test. For example, you are measuring at the end of the 3 days curing concrete mass, this will give you a particular rebound value, and at the end of the 28 days, this will give you the higher value of the rebound compared to the 3 days of the curing of the concrete mass. Next one is the results are not directly related to the strength deformation properties on surface, which is also affected to the rebound value or strength of the concrete mass. Next is the ultrasonic pulse velocity test. This test is performed based on measuring the ultrasonic pulse velocity with the different phases of the concrete mass. And in this method, we are introducing the ultrasonic pulse radiation through the transducer and receive with the receiver's transducers with the different phases of the concrete mass. And the velocity is measured because the velocity of the ultrasonic will different with the different properties of the concrete mass. So after the measuring this velocity, we can easily identify the hardened properties of the concrete mass, and with this principle we can easily measure the hardened property of the concrete mass Here there are the three types of the arrangement you can see on your screen. The first one is the direct method, second one is semi-direct method, and third one is indirect method for the transmitting and the receiving of the ultrasonic pulse rays. In the direct method, the opposite surface is utilized for this test. For example, this is the transmitter and this is the receiver. And in the semi-direct method, here this vertical method and this horizontal method is utilized. You can use this horizontal method and this vertical method, which is dependent on convenience of the test. And the indirect surface, the common surface is used for the test. You can see the arrangement of the three types of the for the ultrasonic pulse velocity test. And after the transmitting of the ultrasonic rays, you are receiving particular velocity of the ultrasonic pulse velocity, and after that you can easily find out the quality of the concrete grade. Here you can see on your screen the ultrasonic pulse velocity is given in the first column, and in the second column the quality of the concrete has been given. For example, ultrasonic pulse velocity which is below 3 km per second, it means the quality of concrete is in doubt. For example, ultrasonic pulse velocity is between 3 to 3.5 km per second. So it means your concrete mass is in medium quality. For example, your ultrasonic pulse velocity between 3.5 to 4.5 km per second. So quality of concrete which is good. If your ultrasonic pulse velocity above 4.5, so it means the quality of concrete which is excellent. Generally, the ultrasonic pulse velocity between 3 to 5 km per second is occurs in your concrete mass. So, with the increasing of the ultrasonic pulse velocity, there is, you can see on your table, there is an increasing of the quality of the concrete mass. It means the increasing of the concrete grade or quality of the concrete mass, there is increasing the speed of ultrasonic pulse velocity on your concrete mass. Now let us discuss about factor affecting the pulse velocity. First one is smoothness of the contact surface. With the smooth surface, there will be accurate result you can achieve with the smoothest surface compared to the rough surface. And second one is the moisture condition of the concrete. With increasing of the moisture, there will be increase the ultrasonic pulse velocity. And next one is temperature of the concrete. It has been estimated that the 5 degree of Celsius to the 30 degree of the Celsius, this will give you the ideal result of the test. If your concrete mass is greater than the 30 degree of the temperature, so this will decrease the ultrasonic pulse velocity of your concrete mass. If your concrete is decreasing the less than the 5 degree of Celsius, so this will increase the ultrasonic pulse velocity of your concrete mass. So the temperature is greatly affect to the velocity of the ultrasonic velocity. And next one is path length. The path length should be sufficient to give you the accurate result of this test. For example, your small element you are measuring. For example, you are taking the beam or the column element which dimension is 300 mm. This will not give you the accurate result. And if you are taking the larger length, for example, the dam which has the higher thickness up to the 30 meter, so this will give you accurate result in this test. So your path should be longest, which will give you the accurate result. And for example, you are testing the small specimen like cube and the cylinder in the laboratories. This will not give you the accurate result with this test. And next one is reinforcing steel. The ultrasonic pulse velocity is 1.2 to 2 times than the concrete mass. So if you are using the reinforcement in your RCC element, so this will affect to the velocity of the ultrasonic pulse. Now let us discuss the application of the ultrasonic testing. First one is the measurement of concrete uniformity. Second one is the detection of the honeycombing in the concrete, because you are applying the rays in the concrete mass, and after the receiving of the rays you are identified the velocity of the ultrasonic rays, and then you can easily identify the honeycombing of the concrete mass and the uniformity of the concrete, and you can analyze the mass of the concrete. And next one is estimation of the strength of the concrete. With increasing of the ultrasonic velocity, there is increasing the quality of the concrete mass. And you can also compare with the higher velocity will give you the higher strength of the concrete mass, particular compressive strength of the concrete. And next one is measurement of the elastic modulus, which is also possible with this test. And next application is measurement of thickness of the concrete rods and the slab. It can be possible with the measurement, with the measuring the velocity, and you can easily identify the thickness of the element for particular rods and slab. And next application is study on the durability of the concrete, because you are analyzing the concrete mass with applying the ultrasonic rays, and you are analyzing the inert material of the concrete mass with the measuring the velocity of the ultrasonic, and then you can easily identify the durability of the concrete mass with this test. So these are the application of the ultrasonic test. Thank you.